James Clerk Maxwell didn't just study the world, he decoded its hidden rhythms. From his pioneering analysis of Saturn's rings to the unifying elegance of his electromagnetic equations, Maxwell revealed the, quote, particular go of the cosmos. This presentation explores how his work laid the groundwork for modern technology and our current understanding of reality. By mastering these principles, we don't just observe nature, we harness its fundamental forces to drive future innovation. Maxwell's genius was rooted in a refusal to accept the superficial. While peers saw gadgets, he saw systems. His relentless question, what's the particular go of it, transformed him from an unconventional Scottish schoolboy into a visionary who unified the laws of physics. This investigative mindset is our greatest asset. It reminds us that true innovation requires stripping away starch and complexity to find the elegant mechanical truths beneath. By embracing this drive for deep understanding, we unlock the power to solve the most intricate challenges of our own era. Maxwell's life was a masterclass in intellectual velocity. From his Scottish roots to the prestigious halls of Cambridge and London, he moved with a singular purpose: to define the laws of the universe. Each milestone on this timeline represents more than a title. It marks a leap in human understanding. By bridging the gap between philosophy and hard physics, Maxwell didn't just join the academic elite, he transformed the very institutions he served. His journey proves that when we maintain a grand simplicity of focus, we can navigate complex systems to achieve world-changing outcomes. Maxwell was a true mechanician, possessing the rare gift of building what he imagined. He didn't just theorize, he constructed. By using simple materials to create sophisticated tools like the dynamical top and the color box, he bridged the gap between complex equations and physical truth. This ability to manifest the abstract is a hallmark of world-class innovation. It shows us that the most powerful solutions aren't just thought, they are built. When we ground our highest theories in practical application, we gain the precision needed to master our field and deliver undeniable results. In 1856, the University of Cambridge issued a challenge that had eluded the greatest minds for centuries: the mystery of Saturn's rings. This wasn't just an astronomical puzzle, it was a fundamental test of stability and motion. By framing the problem through the prestigious Adams Prize, the academic community sought to understand the very structure of our solar system. For Maxwell, this represented the ultimate opportunity to apply his mechanician's mind to a cosmic scale. Tackling such high-stakes challenges is what drives progress. It forces us to move beyond speculation and utilize rigorous analysis to solve the, quote, unsolvable, transforming curiosity into concrete universal knowledge. Maxwell succeeded where others failed by combining abstract calculus with physical intuition. Through 3 differential equations, he proved that solid or fluid rings would inevitably collapse. His solution, a continuous wave motion of independent satellites, was so robust he remained the sole prize winner. By physically demonstrating this motion with his 1858 model, Maxwell provided the clarity needed to turn a 200-year-old mystery into established fact. This approach shows the power of combining deep analysis with tangible proof. It transforms complex uncertainty into a stable, actionable understanding of our world. Maxwell dismantled centuries of misconceptions by proving that color is a perception, not a pigment. Through his experiments, he demonstrated that red, green, and blue light, not yellow, are the true primaries of our visual experience. This breakthrough didn't just explain how we see, it provided the fundamental logic for every digital screen and color photograph we use today. By challenging the, quote, old myths with rigorous experimentation, Maxwell unlocked a transformative understanding of light. This shift from observing surface reality to mastering underlying mechanisms is what allows us to innovate and create the technologies that define our modern visual world. In 1861, Maxwell turned abstract theory into a visual revolution. By collaborating with Thomas Sutton, he proved that 3 black and white exposures, filtered through primary colors, could converge into a single, lifelike image. This wasn't just a lecture demonstration. It was the blueprint for every color sensor and digital display in existence. This outcome illustrates that the true value of any theory is its scalability into real-world application. By mastering the fundamental physics of light, Maxwell gifted humanity the ability to capture and preserve the world exactly as we see it. His success highlights that groundbreaking results come when we dare to apply complex logic to create tangible, lasting impacts. By bridging astronomy and physics, Maxwell redefined the very nature of matter. He realized that gases, like Saturn's rings, are composed of independent particles in constant, chaotic motion. This insight, that heat is simply kinetic energy, allowed him to explain viscosity and diffusion through statistical mechanics rather than solid matter. This shift from observing objects to analyzing invisible systems is a hallmark of strategic genius. By mastering these hidden dynamics, we gain the power to predict and control complex environments. Maxwell's work proves that when we look beneath the surface, we unlock the fundamental principles that govern everything from the air we breathe to the future of thermal engineering. Maxwell's greatest triumph was bridging the gap between intuition and proof. By providing the mathematical structure for Faraday's lines of force, he replaced two separate mysteries with one unified field theory. This transition from viewing forces as isolated events to understanding them as a singular, connected web is the ultimate outcome of high-level strategic thinking. This unification didn't just explain magnetism, it fundamentally redefined the fabric of our universe. In our own work, seeking these hidden connections allows us to streamline complexity and harness the full power of integrated systems, turning invisible forces into the foundation for global technological advancement. Maxwell's journey culminates in the most profound synthesis in scientific history. By mathematically aligning electricity and magnetism with the speed of light, he proved these were not separate forces, but one. This discovery transformed optics into a branch of electromagnetism, providing the foundational code for our modern world. The benefit of this unification cannot be overstated. It is the silent engine behind every wireless signal and digital innovation we enjoy today. Maxwell's legacy teaches us that seeking the singular truth behind diverse data points doesn't just simplify our understanding, it empowers us to command the very spectrum of reality. Maxwell's final masterpiece was not an equation, but a sanctuary for discovery, the Cavendish Laboratory. By ending the era of mathematical trifles, he established a culture where students were empowered to touch the truth through direct experimentation. His meticulous design, down to the very bricks, eliminated interference to guarantee precision. This commitment to building a physical future ensures his legacy continues in every breakthrough made within these walls. For us, the Cavendish represents the ultimate benefit of visionary leadership, creating an environment where high-level theory and practical application unite to foster the next generation of global innovation. Maxwell's greatest legacy wasn't just his equations, but the character of the man who wrote them. He balanced immense intellectual power with an absolute gentleness and a serenity that no scientific challenge could ruffle. By viewing the world through a lens of unselfishness and humor, even in his final days, he proved that true genius is deeply human. This integrity allowed him to lead with quiet confidence, inspiring others not just to calculate, but to explore with heart. As we conclude his story, we see the ultimate benefit of his life, a reminder that our most impactful innovations are driven by a spirit of curiosity, humility, and an unwavering devotion to the truth. James Clerk Maxwell was the architect of our modern world. His equations didn't just explain the 19th century, they laid the tracks for the 20th and 21st. As Einstein and Feynman noted, he closed one scientific epoch and birthed another. By defining the laws of electrodynamics, Maxwell provided the fundamental methods that today bring all of humanity within hearing distance of each other. The ultimate outcome of his genius is the global connectivity we now take for granted. We don't just live in Maxwell's world. We communicate, innovate, and thrive because of the unified reality he first had the courage to map.